everyone, this is AuraML synthetic data cloud platform, which we use to generate synthetic images for our AI ML models, right? So today I will tell you how we can use this platform in order to generate such synthetic images. So we can see that there is a dashboard, there is a login page. So I am already an existing user, so I can simply log into my dashboard. And if you are not an existing user, you can simply go to the sign up page and you can fill out these details like first name, last name, your business email. So anyways, we can move to the sign in page. I will simply log into my dashboard. So you can see the dashboard have a lot of details, so let's understand each and everything one by one. So the first panel here says have a generate data button. So you can simply click on this button and you will land on the page where the data generation process starts. Then in the right you can see your available credits, right? So these available credits mean like one credit is equal to one image. This means if I have these number of credits, I can simply generate these number of images. In the bottom I have my dataset logs, my dataset request logs. So in the past I have requested a lot of datasets to the ORML team, right? And all have a completed status right now, so I can simply view it, download it, and can do many other kinds of operations on my generated data, right? So I will tell you all about these operations you can perform on your generated data in further in this same video. So let's start simply by generating a dataset for us. In order to do so, you need to understand two concepts. The first concept is project and the second is dataset. A dataset is simply the collection of your images which we are going to generate, and a project is a collection of your datasets. So if you want to accumulate similar kinds of dataset inside a particular project, you can simply create a new project and you can create multiple datasets inside it. So just hit the generate data button and the landing page will take care of everything for you, right? So now let's take it step by step. If you want to create a new dataset within a project, follow these steps. Select a existing project from the drop down menu. Click on the virtual environment. Okay, the virtual environment is already selected because a project can hold only one environment at a time. This means all the datasets inside a project will have the single environment, right? In the end, you just have to give it the dataset name which you want, and in the end, you simply click the proceed button, right? But for this tutorial, I will tell you how to create a new project from scratch. So in order to create a new project from scratch, you simply choose the none option from the drop down menu. Select your preferred environment. Like there are enormous number of environments are present here, so I will select the marigold environment. Right, in the end I simply have to type the project and dataset name here. So let's type the project name. So project tutorial and dataset tutorial. Now we simply have to click on the proceed button in order to load the virtual environment. Okay, right. So welcome to the virtual environment or ML synthetic data playground. So to move within the environment, use a combination of shift key plus WASD keys, right? So shift plus W will take you forward, right? And other keys are for standard directional movements, right? For changing the camera orientation, you can simply change your cursor position accordingly, right? Right now like I'm doing this. Now we have covered the controls. Let's explore the playground, like which is divided into three main parts. So the first panel is top panel, like which covers the one generate data button and three icons. Like these three icons are simply the views. So first view is environment view, second view is top view, and third view is camera view. So currently we are in the environment view, in which we can see the whole environment, right? And if I click on the top view, the camera will move to the top 2D representation of the 3D view from above. Okay, then the third option is camera view. We can click on the camera view in order to see the view from the camera. Light tab, whatever you want to say it. So you can see there is a color range, hue and saturation combinedly makes a color, right? Then there is a temperature slider, then there is an intensity slider. So let's see how it works. So if I want to turn my lighting condition into reddish zone, I will simply lower my slider from right. You can see that the lighting condition have been changed into the red zone, right? And if I move my thumb on the slider on the hue range, you can see that wherever I am moving, it is picking the color of that range, right? So if I am in the blue range, it will pick up the blue color. If I am in the purple range, it will take the purple color, right? You can also change its saturation. So if I like keep a really low value of saturation, you will see that the light will not have too much effect. Within each slider, you will notice that there are two thumbs and each thumb defining a specific range, right? So these features allow you to set a boundary within the final dataset light will operate, right? So throughout the playground, you will see these sliders with two thumbs or input boxes for minimum and maximum value. So wherever you go in the platform, you will find such things in which you have to pass the range, and the final data set will lie between these ranges. You can see there is temperature also. You can control the temperature, and in order to control the temperature, you have to like turn on this toggle button. So like if I want to set the reddish zone, I can simply set my left thumb to red zone, right? And if I want to move to the daylight zone, right? So daylight value is around 6500. So if I move to 6500, so you will see that the lighting conditions are almost daylight conditions, right? And in the end you also have intensity. So if the minimum the intensity value, the darker will be the image, and the maximum the intensity value, the brighter will be the images, right? So if I set the intensity to a lower value, you will see that the environment will change to dark condition, lighting condition will be dark, right? Now if we click on this randomize button, so this randomize button will give us a glimpse of how our final data set will look like. So if let's click on this, so you can see that now it's a bright light. You can see this thing. Let's turn off the temperature in order to see more. So if you want to see the color changes, turn off the temperature, and if you want to see the temperature changes, simply turn on the temperature from using this toggle button. So if I hit again randomize light, lighting conditions are getting changed, right? Okay, now the next tab is objects tab. So let's move to the objects tab. So in order to do so, let's move a bit further. So you can see that there is a plus button here, and by clicking on this plus button, what happens is you can place a cube in the virtual environment, right? So this inside this cube you can put your 3D objects. So first we have to click on the screen anywhere in order to place this cube, and it will stop moving. So I will click it here, and you can see that it stopped moving, right? And let's say if you did any mistake in placing this cube, so you simply want to move it to some other place, you can simply go to the right menu panel, and you will find change location of this region, right? So if we click on the change location of this region, and if you simply again move to the environment or the streaming window, you can see that I changed its location. So let's again change it. So I want to keep it in front of me here, right? Like this. Okay, right this. Now let's see what's in the left panel. Objects tab is divided into two sections. The first section contains some accordions, right? And the second section contains the object which can be spawned inside this volumetric region. The accordion is related to this cube, right? So the accordions lets you set the dimension of this cube. If you want to precisely control the position of this cube, you can also do this from accordion. And there are another features like enable physics, volume snapping, generic spawning, right? So enable physics turns on gravitational pull on the objects which are inside this cube, right? So let's say if I want to change its dimension, if I want to change the length of the cube, so I can simply do it like this, and you can see that the cube dimensions got changed, and you can still play around with these values, see what's more accurate, what's more aligned to your dataset needs, right? Now let us simply place some objects inside it. So if I click on this marigold, so you can see I can specify some count here. So let's click on 20 to 30. Okay, so 20 is enough, I guess. You can see that there are a lot of marigold flowers got spawned in this region, right? And you can simply randomize these objects inside it. So you can simply click on randomize button. The placement of the objects will change accordingly, right? So let's try to add some bees on that. So if I want to add some bees over the flowers, what we can do is we can simply click on the bees, and if I specify the count here 500, so you will see a lot of bees. You can see that there are some bees over the flowers, right? And if you click on the randomize button, you will see that the position of the 3D objects or the marigold plants and the bees are changing, like, and all these things will in the end will get reflected in your data set. So this is a really cool feature, I would say. Now in the end, what we can do, in the end we can simply move to the camera tab, right? And we have to place our camera near to the place wherever we want to capture the images, right? And this is the most suitable place for me, like the flowers are coming and the bees are coming, right? Now what else we can do in this camera tab, like there is a resolution settings. So if I set resolutions to 1012, so let's take a standard resolution. 1920 into 1080 is the correct resolution. 080, right? This is the correct resolution, and we can also set the FOV, like field of view. If we want to increase the field of view, we can simply increase its number, right? So you can see that we can change that also. Then we have camera position. If we want to change our camera position precisely, we can do this by, let's say I have to move my camera in the x-axis, so I can simply increase it, but obviously you can play around with these things. Then we have roll pitch yaw. If you increase the roll, you can see that the camera is getting rolled around its axis, right? Okay, we also have dirt mask. So if you want more real world images, you can apply dirt mask on the camera lens. In order to see the preview of any dirt mask, you simply have to click on the thumbnail. So if you click on the thumbnail, and let's decrease some, so let's 40 to 100, you can see the dirt mask is being applied on the images, right? And you can also select multiple dirt masks, and the final images will, in the final image you will see that different dirt masks are getting applied in different images, right? In order to get a glimpse of your final data set, you can simply click on this randomize button as always. So you can see that the dirt masks are being changing, right? I don't want that. And in the end I simply want to correct my lighting conditions, right? So this is the this is good lighting condition. Okay, let's move to the annotation tab which is left. So if we move to the annotation tab, you will see like in which format you want your dataset to be. So currently it is selected to YOLO, but we can select it to COCO format as well. So if I select the Coco format, and it asks us like what kind of annotation you want in your images. Like there are multiple type of annotations in images, as you already know. So I will select bounding box, and as soon as you select these, the final thing remaining is click on this generate data button from the top. You can see that the project name you mentioned, you can see the dataset name you mentioned, and I want 5 images. Like for tutorial, it's fine, I guess, right? And if you want path tracing, so we can also turn it on, but I don't want path tracing, right? So finally, you simply click on the generate data button, and you can see that your requirement has been submitted, right? So let's reload the page and see if our dataset is generated completely or not. So let's hit the reload, and we can see that our dataset name dataset tutorial is now completed. Now let's see what kind of dataset or ML synthetic data platform has generated for us. So let's click on it, and we added some bees, we added some marigold flowers. So like it's really look real image. So these are the RGB images, if you see, and all the images are randomized. So you can see that the position of the marigold plants are different in each images. So that's why we always provided you the option to specify a range. So like these are the really good images. Okay, then we have the RGB images. Then okay, now we can also see the normal, so normal estimation images. So then we have semantic segmentation. So the only mask available here is for B. So all the B's are well annotated, if we can see that. Also, we have masks too. So these are the instance segmentation masks. So you can see that all the colors, all the B's are of different color. You can also see few details of your dataset here. So environment was marigold, number of images you specified was 5, resolution we specified was 1920 into 1080 standard size, right? And then we have the annotation types we selected, right? Annotation format Coco we selected. We can also see lighting condition, you can see here, right? The camera details, what was the position of the camera XYZ, then roll picture, then FOV. You can see that we specified the FOV to 105, if you remember that thing, right? Let's download the dataset. So let's click on it, and yes, we want to download the data. So you can see that we have already downloaded the dataset from our AuraML dashboard. So it's all you can see the zip file in the downloads folder. So first we have to unzip it. So let's unzip it, and you can see that there are a lot of folders and some JSON file in there. So we can see that there is a folder named normal, RGB, semantic, and mask. Then we have a Coco file, right? Because we downloaded the annotation in Coco file, right? So let's see one by one each of them in the VS Code. So let me open the VS Code first. So if I see the Coco file, so the first thing is annotation. So you can see that there are a lot of annotations happening in there. So this is an annotations array, and you can see that there is an area, box, category ID, right? Then there is like segmentation polygons, right? So we already understand annotations, right? Then we have categories. So in already in the on the dashboard, I have shown you that the only the B's were getting annotated. So that's why we have only B here in the category, and the black background, which I already showed you, right? So the black background was this in order to get more focus on this thing, right? Then we have images. You can see there is camera properties, which you already know, right? And we have already seen the semantic images on the dashboard as well. The RGB images, which is really required, right? So RGB images are really high definition, as you can see. You can see the bees. Also, we can see the dirt mask we applied during the data generation process, right? So you can see that lighting conditions are also getting changed. This is a really like diverse data set. You can see that lighting conditions are getting changed. Temperature is getting changed, right? All right. Then we have normal images as well. So you can see that. Then we have instance mask as well. So you can see that in instance mask, all the bees are annotated with different colors, right? So yeah, so that's all about the data set. Now we'll move back to the dashboard and see what's left in the demonstration. And yep, in 2 minutes only you got all the data related to its Coco file, all the images, all the semantic mask, all the instance mask, right? So it's a quite diverse platform. You can do any kind of, you can apply any kind of permutation and combination in the environment by manipulating the environment, and you get a top-notch data set available in the market, right? So it's a highly useful tool. The next thing is, let's say you created this data set, right? And you don't want to do the same kind of configuration again and again in the same environment. So what you can do, you basically want to continue from the last point you stopped, right? So what you can do is, you can see a button called recreate dataset in right of the download dataset. And if you click on the recreate dataset, what it will do is, it will take all the state of the previous dataset you created, and you just have to put the new dataset name. So dataset uh, tutorial 2, and it will make you fall to the same state where you left in the last dataset you created. So it's like recreating the same state again. And let's see, like right. So let's wait for a few more seconds. So you can see that we spawned those marigold plants and the containers dimensions are also same. Like the lighting conditions are also same. You can see that all the lighting condition you done is already mentioned here. The object you already spawned is mentioned here. Each and everything, the count, the plants count, everything is same, exactly same here. The annotation you selected is exactly same here, right? So you don't have to do the same drill again and again in order to reach to a certain level, right? So you can create a data set, then you in the future you can continue from this from that data set as well, right? Cool. So we have learned about how this platform works. We learned about how to manipulate the virtual environment, basically how to play in the playground, right? And we also have seen that generated data set, how it looks, what all kinds of file it provides you, right? So let's say your image credits got empty. You don't have any image credits right now in your account. So how will you get the image credits? So if you click on the get more credits button, right? So you will get a prompt. So in this prompt, you can mention all the requirements you want, like why do you want these credits and how much credits do you want. And if you submit this form, AuraML engineering team or AuraML team will reach you out very soon related to the credits, right? So it's a quite good thing. And like if you got anywhere stuck in the platform, like if you don't know how to navigate further, if you don't know what are the default values of any kind of setting in the playground, right? You can simply come to this customer supports panel and you can write the subject, you can write the description, and voila, submit. And in the end, what will happen? The ORML team will review your application and will guide you throughout the process to do. Yeah. So that's it. So that was about the whole synthetic data platform of ORML.